keep an eye out for the prize.
Hello and welcome to the practice problems video on planes in 3 space. Alright, so this question asks us to find the equation of the plane passing through the following points: P, which is 2, -1, 4, Q, 1, 1, 1, and R, 3, 1, -2. Okay, so first of all, what we have to do is, so we're given 3 points in the plane, 3 points that make this plane unique. Okay, so we have a P, a Q, and an R. Okay, and now, so here's the plane that they form. Alright, and now what we have to do is find the equation of this plane. So for an equation of a plane, what we have to find out is, so we have to figure out the normal. That's one of the most important parts. And then we have our x, y, z. Those are just variables. They're just going to sit there at the end. They're still going to be in our equation at the end. And then we have our n, our normal again, and that is dotted with a point in the plane. So we could pick anything for that one at the end. But anyway, so the first thing we should do is find this normal vector, which shows up twice in our equation in some way, shape, or form. So to find the normal, given 3 points, what we have to do first is find 2 vectors in the plane, okay? And we can utilize the points that we are given, okay? So we'll find a PQ and then a PR. So first, to find PQ, what you're going to do is take the endpoints, the components of the endpoint, so 1 for the first component, and subtract off the components of the start point, so -2, 1 minus a -1, and 1 minus a 4. Okay, so this is going to turn out to be a -1, a +2, and a -3. So these are the components for our first vector in the plane. Okay, and then the next one we'll find is PR vector. Okay, so we'll do the same thing here, but this time our endpoint is R. So then we'll have 3 minus 2, and then a 1 minus a -1 again, and a -2 minus 4. Okay, so this is going to turn out to be a 1, a 2, and a -6. Alright, so here we found these 2 vectors in the plane, and now what we have to do to find our normal vector is cross these 2 vectors. Okay, because taking the cross product produces a vector. The resulting vector is perpendicular, or aka orthogonal, to both of the original ones. So that's what we want to find, is this normal vector that sticks out of the plane perpendicularly. Okay, so the way we do this is we're going to cross those. So we set up our I hat, J hat, K hat. Okay, and then we set up PQ along the middle row, so -1, 2, -3. And then we have our 1, 2, and -6 at the bottom there. Okay, so I'll continue solving this on the next slide where we have more room. Alright, so we're going to do I hat first. I'll just write this down for your guys' reference. Okay, there we go. And here's this again, so -1, 2, -3, 1, 2, -6. Okay, so we're going to do I hat first, so we have I hat here, and then our minor, so 2, 2, -3, -6, minus J hat, because that comes from the formula for computing the determinant. So then J hat here, and our remaining numbers are -1, 1, -3, and -6. And finally our K hat, so we cross those out, and we have -1, 1, 2, and 2. Okay, so now that we have that, we're going to continue and say that I hat times 2 times -6 is a -12. And we're going to subtract off a -6, which comes from 2 times -3. So like that and like that. And then minus J hat, and we have a -1 times -6 is a +6 minus a -3, so that'll end up being a +3, right? And then we have our plus K, and that's times -2 minus a +2. Okay? Alright, so moving along, so we have I hat times, and these turn positive, so -6 goes there, and then this is minus a 9, J, plus a K hat times -4. Alright, so our resultant vector is going to look like -6I minus 9J, and then minus 4K hat. Alright, so this is the same thing as -6, -9, and -4. Okay, so what we can do now is, so this is our normal vector. We found that, so that's good. This is our normal vector, yay. And now what we need to do is just construct the equation for the plane, right? Okay, so keep this in mind, and I'll continue writing that on the next page. Okay, so again, our formula for the equation of a plane is the following. So normal vector dotted with x, y, z is equal to normal vector dotted with some point on the plane. That's what that means. With a vector representing some point on the plane. Okay, so first of all, we have -6, -9, and a -4 dotted with x, y, z. And then we have the same thing, -6, -9, and a -4 dotted with, and I think I'll pick the 2, -1, 4. So I'll just pick point P, okay? So that's 2, -1, and 4. Okay, so again, this is point P, the vector representation of point P. Okay, so on the left side, all we have is -6x minus 9y minus 4z. And that's going to be equal to -6 times 2. I'll just write it out. -6 times 2 plus -9 times -1 plus -4 times 4. All right? So then this on the left just stays the same for now. Minus 4z is equal to -12 plus 9, so that's a -3, minus 16. Okay, so -3 and minus 16 is a -19. And then on the left side we have the same thing. And as you can see here, we can just divide everything by -1 because I don't like negative signs. And it just looks nicer. So 6x plus 9y plus 4z equals a positive 19. Okay? So this is our equation of the plane. Okay? And this is not a unique solution. Okay? So we could have ended up with a different number here if we had used a different point on the plane to plug in to get our d. You know, the a times x naught plus b times y naught plus c times z naught. Let's say we had used instead q, the point q, which equals 1, 1, 1. Then we would have gotten what? -6, -9, -4. So that would, that actually would have been the same thing. Interesting. But anyways, so the point is, you're going to get an equation of the plane, but it might just, even without using one particular, like you didn't have to use just point P. You could have used point Q and gotten the same thing, or even point R, which we started with, which is 3, 1, -2. And you could have gotten the same answer as well. Okay? So anyway, so this is our answer, and now on to the next question.